when we solve a right triangle, we're finding all of the side lengths and all of the angles. Most applications, we're going to just care about one particular side length or one particular angle, and we've just got to interpret the situation to figure out what that is. So I've got a problem on the board. This is an even numbered problem from your text. So an airplane is going to begin its descent with an average speed of 240 miles per hour at an angle of depression of 4 degrees. So I'm going to draw my picture. Here's my airplane. I am going to represent my airplane as a dot because I am hopelessly bad at drawing airplanes that look like airplanes. Okay, now I'm going to just draw a dotted line here. That would represent the path the plane would be flying along if it stayed at a constant altitude. But it's not. It's going to start to descend, and we're told that the angle of depression is 4 degrees. That angle of depression is the angle that the plane is going to make with this sort of imaginary line at a fixed altitude. So this angle is 4 degrees. Okay. All right. And we're asked how much altitude will the plane lose in 5 minutes. So if this represents the distance that the plane goes in that 5 minutes, we're really concerned with this right here. I'm going to label that A for altitude. And if this is coming straight up and down, and this was straight horizontal because it was at a fixed height, we've created a right triangle right there. So I want to know this side right here, which is opposite the 4-degree angle. And so I'm going to need to know one of the other sides. And I wasn't given that information directly, I was given it indirectly. I was told how fast the plane was flying and for how long. Now I know I can calculate a distance as a rate times a time. I'm just going to have to be a little bit careful about the units here because this is miles per hour and this is time in minutes. But I can say my distance is going to be 240 miles per hour. And 5 minutes, I could view that as 5/60ths of an hour, because there are 60 minutes in an hour. Then I can see those hours would cancel, and I'd be left with miles, which is what I want. Another way I could think about that is I'm taking my 240 miles per hour, I'm multiplying it by 5 minutes, you just put that over 1. Right now, none of my units would cancel, but I could say that 1 hour is the same as 60 minutes. So I could multiply by this form of 1 in the form of that same amount of time, 1 hour, just expressed in different units, and then I can see my hours cancel, my minutes cancel, and I'm just left with miles. Okay, so let's see. 60 would go into 240 4 times. 4 times 5 would be 20. So that would be 20 miles. Now, which side of the triangle is that? Well, that was the distance that the plane traveled. The plane was not staying at a constant height. The plane was coming down. So that's going to be 20 miles right here. So that's the hypotenuse of this right triangle. And so now I can see I could go ahead and solve for A. I've got an angle, I've got the opposite side, and I've got the hypotenuse. So let's use sine. So I'm going to say sine of 4 degrees is A over 20. A is 20 times sine of 4 degrees. And I want to pull out my calculator. Now, I just used this a minute ago, so I know it's still in degree mode, but make sure when you are using a calculator that you check that you're in the right mode, because that can really mess you up if you're not. So I'm going to just type in 20 times sine of 4, and so I get 1.395 blah, blah, blah. And we were asked to round to the nearest tenth of a mile, so that would be this place. With this being a 9, I'm going to round up. So I would say about 1.4 miles. All right, so you've got a couple problems similar to this in the homework, where basically you've got to take a paragraph of information and draw me a picture. And that picture will involve a right triangle, at least in this section. And then you're just figuring out what sides do I know, what angles do I know, and what information am I trying to solve for.